periodic table. When Mendeleeve started his work, 63 elements were known. He examined the relationship between the atomic masses of the elements and their physical and chemical properties. The formulae of the hydrides and oxides formed by an element were treated as one of the basic properties of an element for its classification. Based on his observation, Mendeleeve formulated a periodic law, which states that the properties of elements are the periodic function of their atomic masses. Mendeleeve's periodic table contains vertical columns, called groups, and horizontal rows, called periods. R, in the periodic table, stands for elements. The formulae given at the top of each group are those of oxides and hydrides, formed by the elements of that group. The numbers given below the symbols of elements are the atomic masses of the elements. For example, atomic mass of hydrogen is 1.008. Mendeleeve arranged all the elements in the order of increasing atomic masses in horizontal rows in such a way that the elements having similar properties came directly under one another in the same vertical column or group. The similarity in the formulae of oxides and hydrides was used as the basis to classify elements with similar properties. For example, lithium, sodium, potassium form oxides as Li2O, Na2O, K2O, respectively. Hence, they have general formula R2O. Similarly, other elements form oxides having general formulae, such as RO, R2O3, RO2, R2O5, RO3, R2O7, and RO4. Now, let us consider the formulae of hydrides. For example, the elements lithium, sodium, and potassium form the hydrides LiH, NaH, and KH, respectively. Thus, their general formula is RH. Other elements form hydrides, having general formula of RH2, RH3, RH4, RH3, etc. Thus, Mendeleeve's contribution was the most important for arrangement of elements in proper order. The modern periodic table. In 1913, Henry Moseley decided to reframe the periodic table on the basis of atomic number. The idea behind this was that the atomic number increases regularly by 1 from element to element. The atomic number of every element is fixed, and no two elements can have the same atomic number. Thus, we can say that it was the discovery of atomic number which led to a change in Mendeleeve's periodic law, which was based on atomic mass. According to modern periodic law, the properties of elements are a periodic function of their atomic number. It means that, if the elements are arranged in tabular form, in order of increasing numbers, then the elements having similar properties will occur after fixed intervals. The modern periodic table has 18 vertical columns, known as groups, and 7 horizontal rows, known as periods. When elements are arranged according to the increasing atomic number, there is a periodicity in the electronic configuration of elements. The periodicity in electronic configurations of elements leads to the periodicity in their chemical properties. The number of elements in a period is fixed by the maximum number of electrons which can be accommodated in the various shells of an atom. For example, K shell 2 into 1 square is equal to 2. Hence, the first period has 2 elements. L shell 2 into 2 square is equal to 8. Hence, the second period has 8 elements. M shell 2 into 3 square is equal to 18. But, the outermost shell can have 8 electrons, so the third period has 8 elements only. The position of an element in the periodic table tells us about its chemical reactivity. In the modern periodic table, the elements have been roughly divided into metals and non-metals. The elements on the left side of the periodic table are metals, whereas those on the right are non-metals. In the periodic table, metals and non-metals are separated by some elements, called metalloids, which are placed diagonally in the periodic table. The groups 1 to 2 and 13 to 17 contain normal elements. All the elements in a group have similar electronic configurations and show similar properties. For example, Group 1 consists of alkali metals, lithium, sodium, potassium, etc. All have one valence electron in their atoms. Group 18 elements are known as noble gases or inert gases. For example, helium, neon, and argon. They have 8 electrons in their outermost shells. But helium is an exception. It has only 2 electrons in the K-valence shell. Hydrogen is placed on top of group 1, above the alkali metals, because the electronic configuration of hydrogen is similar to those of alkali metals. But, while discussing the alkali metals of group 1, hydrogen is never included, because many properties of hydrogen are different. Now, let us see how elements are arranged in modern periodic table on the basis of their electronic configuration in groups. Elements having 1 valence electron are placed in group 1. Elements having 2 valence electrons are placed in group 2. Elements having 3 valence electrons are placed in group 13. Elements having 4 valence electrons are placed in group 14. And so on. Thus, we can say that modern periodic table rectifies the limitations of Mendeleeve's periodic table.